आज का वीडियो मुख्य रूप से रसायन के उन विद्यार्थियों के लिए बहुत ही उपयोगी होगा जो 10वीं कक्षा से 11वीं कक्षा में प्रवेश विज्ञान के अध्ययन में प्रवेश पा चुके हैं. The video will be very useful for those students who have passed class 10 and are moving to class 11 and have been admitted uh, in class 11 with science stream. I congratulate such students. They must have scored high in their earlier examination. But before we step into class 11 and study different topics of our syllabi in chemistry, it is very necessary that we should strengthen our basic concepts. May it be whatever simple. So, with this view, we start from the very beginning and take up with the terms like elements and compounds. Okay, what are elements? Different definitions can be given, but in a simpler sense, elements are the substances or matter which cannot be decomposed into anything simpler than itself. तत्व वह पदार्थ हैं जो अपने से सरलतम भाग में परिवर्तित न किए जा सकें. Of course, we have to learn the characteristics and the properties of these elements separately and in a detailed or magnified manner than what we have taken in class 10th. I'll advise you to go through the names of the elements and their symbols given as an appendix at the end of the book you are or you might be having. Normally, elements are represented by their symbols. So, what are symbols? Symbols are the abbreviated form for writing the names of an element. These symbols are very conveniently represented by certain letters which have been picked up either from their English or Greek or even Latin words. For example, the symbol for hydrogen is H. The symbol for lead is not PB, not LE. Actually, it is PB. And PB is the word derived from plumbum, P capital B small. Sulfur is S, selenium is Se. So we find that every element can be represented by their letters, and these symbols have to be used very frequently by a chemist or by us. Then when these elements combine together, they result into the formation of molecule. The combination takes place under certain conditions of temperature, pressure, and might be the use of the catalyst and many other conditions which we have to require to settle. So, the substance or the product which we get is known as compounds. These compounds are also represented by using the symbols of different elements present in them in suitable ratio. And then the abbreviated form of symbol for abbreviated form of compounds using symbols of the elements present in it is known as molecule. Please note, there is a big difference between symbol and molecule. Molecules are composed of atoms and they have their own weight. Now, these compounds may be either inorganic compounds or organic compounds. We shall learn details of organic compounds in certain unit, and very frequently we are using inorganic compounds. Now, inorganic compounds are classified as acids, bases and salts. Acids, bases and salts. These are known as inorganic compounds. Either it may be an acid, it may be a base, or it may be a salt. Now, we are required to write the names of the acid or formula of the acid and formula of the base or the formula of the compound. How do we write? We have to learn the formula of a compound. Presently, we take up the formula of how to write the formula of a compound, inorganic compound. Organic compound, of course, have a different way of naming them. We shall learn it later on. But presently, we shall take up inorganic compounds. Let us take a very simple example. Any inorganic compound, it may be an acid, it may be a base, or it may be a salt. Whatever it is, it consists of two parts, the acidic part and the basic part. Now, these basic parts are known as cations. They are species which are deficient of electrons and therefore we call them cations. हिंदी में उसको धनायन भी बोलते हैं. And each cation has got its own formula. Its own formula. For example, let us take up a case of AB, a general case. A is positive. Why it is positive? Because it has lost electron during the course of a reaction and it is short of electron. Therefore, we write it positive. And the number of electrons lost represent its valency. Now, this valency is given by certain number with a positive sign. If only one electron is lost, we need not write the number. But if more than two electrons are lost, or if the cation is bivalent, trivalent, we use 2 positive or 3 positive and write it as a superscript as you find here. Contrary to this, the negative part of a compound is having an excess of electron, and therefore that is represented as B minus. Again, the number of electrons in excess is represented as a negative sign. Normally, if one electron is in excess, we need not write minus 1 or 1 minus. We simply put a minus sign there. But if the valency is more than 1, we call it 2 minus or 3 minus, whatever is there. So we have to learn the names of different cations and their valencies. Actually, a number of cations we shall come across. And for example, you must have heard there is anion carbonate ion, sulfate ion, sulfide ion, cuprous ion, cupric ion. Isn't it? Now, all these ions, you have to learn their symbol and valencies. Only then it will be possible to write the correct formula of a particular compound. I provide you here a list of certain cations and anions. In fact, the list is much more than what is being given here. So for your convenience, I am giving you the list here. Now coming back, how to write the formula of a particular compound. Say, let us take the case of aluminum sulfate, which consists of Al, 3 positive as the cation, and SO4, 2 negative as the anion. SO4 is a group of atoms which act like a single atom, and therefore we call them as radicals. And so negative part is SO4, which is bivalent, 2 negative, and positive part is Al, 3 trivalent, 3 positive. We write, please note, we write positive part first, the symbol of the positive part along with the suitable valency. Okay. It is Al3 plus, as you find here, and SO4, 2 negative. If you write it side by side, cation first, anion thereafter. And the only thing we are required to do is that cross transfer their valencies. By cross transfer, we mean the negative valency to be written with the positive part, that is cation, as a सबस्क्रिप्ट, नीचे की तरफ लिखना है, ऊपर नहीं, ऊपर तो वैलेंसी लिखे हैं. So, and the positive part is written as a subscript with the sulfate. That is what is shown here, and you get Al2SO4 three times. Now, take care that SO4 is a radical. Therefore, we write it within brackets, and outside the bracket we write 3 as a subscript. नीचे की तरफ ब्रैकेट के अंदर तो हम रेडिकल लिखेंगे और नीचे की तरफ हम 3 वैलेंसी क्रॉस ट्रांसफर के बाद जो भी आया वो हम लिखेंगे. So the formula is Al2SO4. That way, calcium chloride is CaCl2. CaC2O4 is calcium oxalate. C2O4 again is an anion. It is a radical again, having 2 negative charges. Calcium, a cation, having 2 positive charges. So if you cross transfer 2 negative and 2 positive, 2 negative with calcium as a subscript, 2 positive as subscript along with oxalate ion. So we get Ca2C2O4 2. Now writing Ca2C2O4 is not necessary. The common divisible number is taken out and the formula becomes CaC2O4. Similarly, Mg3PO4 twice is known as magnesium phosphate. It will be better that you practice writing the correct formula of a particular inorganic compound. May it be acid, may it be a base, or may it be a salt. We shall get more details about acid and bases, but mind it, acids always contain H as a cation, and bases usually contain OH, that is hydroxide as a anion. That's why whatever acids you take, say sulfuric acid, it is H2SO4, hydrochloric acid is HCl, nitric acid HNO3, oxalic acid H2C2O4. That's way. That is how we write acid. For bases, say NaOH, sodium hydroxide is a base. KOH, potassium hydroxide again is a base. All bases contain OH. Or when they dissolved in solution, when they get dissolved in solution, पानी में मिला दिया जाए, उनका सॉल्यूशन बना दिया जाए, तो वो OH आयन देते हैं, बनाते हैं सॉल्यूशन में, सो उनको हम बेस बोलते हैं. That's there. Now the second topic which we have to discuss is about mass number, atomic mass and molecular mass. What is understood by mass number and atomic mass? Please note that mass number and atomic masses are the two terms very usually used. Mass number is always a whole number. उसमें कोई डेसिमल पॉइंट नहीं होता. और आगे हम पढ़ेंगे भी, और शायद हमने 10th में भी हमने एक आइडिया लिया है, दैट मास नंबर इज द सम ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स present in the nucleus of an atom, of an element. So it is always a whole number. But what is atomic mass? Atomic mass may be fractional also. Why? Because it is the average of the isotopic masses of a particular element. हमको अभी आइडिया है, मालूम है कि कोई भी एलिमेंट के विभिन्न समस्थानिक रूप होते हैं, जिनको हम बोलते हैं आइसोटोप्स, जिनका एटॉमिक नंबर तो वही होता है, लेकिन एटॉमिक मास नंबर अलग अलग होता है, और उनका परसेंटेज जो नेचर में या प्रकृति में पाया जाता है वो भी अलग अलग है. तो हम उसका एवरेज निकाल करके हम एटॉमिक मास बताते हैं. और एटॉमिक मास चूंकि एवरेज है, ये फ्रैक्शनल भी हो सकता है, एंड यूजुअली मोस्ट ऑफ द एटॉमिक मासेस आर फ्रैक्शनल. सो वी यूज एटॉमिक मासेस फॉर कैलकुलेटिंग द मॉलिक्यूलर मास. The mass of one molecule is obtained by using the atomic masses of the elements present in the molecule of a particular compound in suitable ratio. That is the number of atoms. Now we shall have certain practice to calculate the molecular mass. How do we calculate the molecular mass? Molecular mass is calculated by writing first the correct formula of the particular compound. For example, AgCl. AgCl is known as silver chloride. Silver chloride. And if you have written correctly, of course it is correct here, we write the atomic mass of silver and the atomic mass of chlorine. Since one atoms are there for both, एक सिल्वर का एटम है, एक क्लोरीन का एटम है, तो हमने दोनों का एटॉमिक मास लिखा और इसको जोड़ दिया. Adding up the atomic masses of the various atoms present in a molecule gives the molecular mass of a particular compound. So 108 plus 35.5, ये इसका एटॉमिक मास है क्लोरीन का, और 108 सिल्वर का. जोड़ने के बाद 143.5 आता है. Well, that is the atomic mass of silver chloride. Now, here I must make it clear about it that Actually, the atomic masses given in different uh, literature is fractional. For example, silver is given as 107.8692, and chlorine, if you look at the data, we get 35.453. प्रायः ये डेसिमल में रहता है, एटॉमिक मासेस हमने आपको बताया डेसिमल में है, और अगर आप इसको जोड़ेंगे, ऐड अप करेंगे, तो यू गेट 143.32. 143.32 तो है, that is the correct atomic mass, but usually we round it up, and after rounding up properly, whatever we get, that is known as nominal molar mass or nominal mass simply. And therefore, instead of writing 143.32, we just write 143.5. क्लोरीन का जो लिटरेचर में दिया है वो 35.453 है, हमने इसको राउंड अप कर दिया, राउंड अप किया, इट बिकम्स 35.5. It makes us convenient to calculate, and therefore we get a nominal molar mass of nominal, that is 143.5. Similarly, H2SO4. Look here, H2SO4 contains 2 hydrogen atoms. 2 into the atomic mass of hydrogen is 1. Actually, it is 1.008, but for our calculations here, we take 1. So 2 into 1, sulfur is 31.99 something. Rounding it up, you get 32. Oxygen is 15.999 something. You may take it as 16. And since 4 oxygen atoms are there, we multiply by 4. Add them up the way it is written. You get 98. अब ये जो मोलार मासेस हैं सल्फ्यूरिक एसिड के, हाइड्रोक्लोरिक एसिड के, नाइट्रिक एसिड के, सोडियम हाइड्रोक्साइड के, ये तो धीरे धीरे करके आपको याद रखना है. You have to keep it memorizing the atomic masses and even the molar masses. Similarly, NaOH is 40, calcium hydroxide is 74. These are the nominal masses, nominal molar masses or molecular masses. And so that is how we calculate. And there is something like equivalent weight. The details about equivalent weight we take up a little later.